Good morning, friends. Even though I'm not at school today, you are still going to be doing Eureka Math, and we are going to be looking at Lesson 26 today. So you need to have your green math book with you. I hope you already do. And you need to find Lesson 26 problem set and homework and rip those out. If you don't have your green math book, then you need to do that now. Maybe pause the video so that you have time. Okay, I'll give you a minute to rip out your papers. Okay, friends, so if you're looking at Lesson 26 problem set, and you look at number 1, let's read the instructions. They say partition the number line to show the fractional units. Then draw number bonds using copies of one whole for the circled whole numbers. Copies of one whole means, what is one whole equal to? In this case, if you're looking at number 1, we're talking about halves. So how many halves are in one whole? We're going to use our number line to help us, okay? So if you look at your number line, it kind of looks like this, and it says halves off to the side. It said to partition. And remember, partition means that we're going to break it apart. We're going to split it up into halves. So think about how many equal parts are in halves, and there are 2. So I'm going to split between 0 and 1 into halves, into 2 equal parts, because that's one whole. Okay? And then I'm going to come down here and split 1 and 2 into halves, because that's also one whole. Okay? So then down below it says 0 equals blank halves. How many halves are in 0? If we look right here, how many halves are there? None. So 0 equals 0 halves. And then down below it says 0 is also equal to something over 2. Well, we've labeled lots of number lines, so we know that 0 is also equal to 0 halves, 0 out of 2. Okay? And now below the 1, I'm going to erase this one. Below the 1, it says 1 equals blank halves. Well, how many halves are in one whole? You can start at 0 and then count. 1 half, 2 halves. Okay? So there are 2 halves in one whole. That's why we get 2 over 2 with one whole. So if you want to go back and label your number line, you can. So it looks something like this. Okay, and then below the 1 equals blank halves, they've got 1 equals something over 2. Well, we know that 1 is equivalent or is the same as 2 over 2. Okay, and then they gave us a big number bond with a 1 in it. And they want to know, how can you use copies of one whole to represent 1? Well, you would just give it one arm because there's only 2 out of 2 there. Okay, that's a copy of one whole. It'll make sense once we get to the next one. Okay, the next one says 2 equals blank halves. Well, if you labeled your number line, or if you look at mine, you can see that in 2 there are how many halves? Oop, I messed up. This should be halves, not fourths. So how many halves are in 2 whole? 4 halves. See? In 2 there are 4 halves. If you started back at 0 and counted, you would count 1, 2, 3, 4 halves in 2 whole. Then they already did this part for you. 2 equals 4 over 2, 4 halves. And then they gave us a number bond, and they want us to use the copies of one whole, and they gave one to us, 2 over 2. Okay, 2 over 2 is the same as 1. So then how many more halves to get to 2? 1, 2. So another 2 over 2. Another 1 whole, which is also represented by 2 over 2. Okay, Okay, I want for you to go ahead and turn your paper over, and let's look at number 3. Okay, number 3 is going to be similar to your exit ticket today, where it's going to give you some information and ask you to split up a wire or a piece of yarn or something into fractions. Okay, so this says Sammy uses 1/4 meter of wire each day to make things. Letter A. Draw a number line to represent 1 meter of wire. So you make your number line just like you always do on letter A. Your endpoints are 0 and 1 because he only has 1 meter. It says partition the number line to represent how much Sammy uses each day. How many days does the wire last? Well, if you go back up to the very first instructions next to the number 3, it says he uses 1/4 of a meter of wire each day. So you're going to want to break your number line into fourths. Remember, I split it into half and then half again to try and get nice even parts. Okay, so if he has 1 meter of wire and he uses 1/4 each day, how many days can he use 1 meter of wire? Well, 1, 2, 3, 4 days. So letter A would be 4 days. And then it says, letter B, how many days will 3 meters of wire last? Well, if 1 meter of wire lasts 4 days, then we can find out how many 3 meters. So if 1 day equals 4, 3 days equals what? We can multiply 3 times 4, and we know that 3 times 4 is 12. So 3 meters of wire would last him 12 days. If you wanted to draw out 3 different number lines like this to show your thinking, you're welcome to, but you don't have to. Okay, so today I want you guys to be focused on partitioning out those number lines into even equal parts because that's what fractions are. You may label them if you need to. You are going to finish the problem set today and begin on the homework if you get finished with that before you do some other stations and then get your exit ticket. So I hope you have a great, wonderful Friday, and I will be teaching you another lesson on Tuesday. Have a good weekend, guys.